Welcome to the Utah Water Conservation Forum's virtual spring conference. We have a great lineup for today's session. We'll kick things off with 3 short presentations covering how Utah State University's water research is influencing change in Utah. We'll follow this up with a Q&A session. After a short break, we'll switch gears and cover gray water in Utah.
I just wanted to give a little welcome and thanks for those who are joining us for the first time or coming back. We're always happy to have you, and this is something that we do every year. We have a spring conference, so we'd love to see you for future conferences as well. We try to keep our topics very diverse and focused on water conservation, and we have a wonderful lineup today. I also want to let you know that we offer a fall tour, and we don't have dates solidified yet, but we'll be reaching back out to those who have registered and letting you know of a fall tour in the future. And with that, I'll turn it over to Kelly Cope and with USU and have her introduce her group to you. Thanks.
Thanks, Rick, and thank you, Candace, for moderating today. It's my great pleasure to moderate this session today. These are all colleagues of mine who do wonderful work in the area of water conservation. And our first speaker is Dr. Melanie Stock. She is a soil scientist, and her lab focuses on high-value crops and resource use efficiency to improve the environmental sustainability and economic viability of small farms. And I would also like to promote her Instagram, which is a tremendous resource as well. I'm going to put that in the chat, but it is at USU_small farms. And with that, I will turn the time over to Melanie.
Well, thank you so much to everyone who's here today and for Dr. Kopp for the introduction. So today I'm going to be talking about some very early research coming out of USU that's looking at the time of day for irrigation and water losses associated with that. So I just want to quick recognize the sponsors of our research. We're so thankful to these water conservancy districts who have funded us, as well as USU Extension and my graduate student, Sammy Picarell. She's done a lot of work on this. So let's get right into it. One of our conservation methods here in Utah to save water is to irrigate at night. And so here's a graph that looks at the water use over a 24-hour schedule, so 0 being midnight, and going through the day. And you can see here that most of our water use is happening at night. And so this is thought to be a conservation strategy. If we're using sprinkler irrigation at night, we might be reducing water losses. And so this is kind of a long-held belief. The conditions at night may reduce losses from evaporation. So conditions, or microclimate, we like to call it. The temperatures are cooler, there's no bright shining sun, there's higher humidity, so that'll result in less evaporation, and presumably less wind as well. And that's generally the case for most areas. And so I like to think about this like if I were drying clothes on a clothesline, that if I put them out at night, it's going to take a lot longer for them to dry than it would if I put them out in the middle of the day. And so this is a really common practice throughout the state. However, with our population growth, demand now exceeds capacity. So for everyone to be watering at night, it's actually a bit of a challenge for our system. And so the question came, how much water are we really saving? And that's what we're aiming to answer. And so I won't go into detail about this, but there has been a little bit of work done internationally where they're looking at wind drift and evaporative losses from day versus night irrigation, generally finding that day has greater evaporative losses than at night. Separate studies have looked at ET, and we'll talk a little bit more about what that is coming up here, but they've looked at ET and they've actually found that if you water during the day, it cools the microclimate around the plants, which reduces stress for the plants, and then ET actually can go down. So there's actually these two competing processes that are happening that make this simple question actually quite complex. So our questions were, well, what happens if we're testing this in Utah? What happens if we're looking at urban crops? These other studies have been looking at things like alfalfa and maize. But what about if we look at turf grass or garden crops? And what happens if we have one study that's looking at all of these processes together? How does that even out, or how does that work out? So the goals of our study are to do just that, to measure the water efficiency of day versus night irrigation. We chose 2 urban crops, so turf being the #1 urban crop, most irrigated by sprinklers, not so concerned about drip, and then also zinnia cut flowers, which seem a bit random. They're a very common garden flower for people. They're also a common cut flower for our urban farms. And on top of that, they just have such a different canopy architecture, if you will, right? The shape of that plant is just so much different than turf. It starts with bare soil when we seed it in, and then it grows up to be about 3 feet tall. And so how is that going to affect the way water distributes? And so we're looking at all the places the water can go to understand losses, and then also looking at the plant productivity and quality. So does it look better or worse if we're irrigating at one time or another? So this study is set up in North Logan, Utah at our research farm. We installed in the middle of summer of 2019. So our first full year was last year, and then we've got another full year coming right now, actually. And so it's a bit busy, but I just want to show that we've got a lot of plots in the field. And we're looking at turf and zinnias that are irrigated at night and during the day. And so our 2 timings are from 2 to 4:30 a.m. and 2 to 4:30 p.m. Okay, so let's now kind of picture where the water goes once we irrigate, right? The sprinkler comes on, the water comes out. We really hope it all goes into the soil. However, there's other places the water can go. So it could run off. We're not irrigating that much, so we can actually cancel that off. We don't have to measure that. But some of it can drift away, right? After it leaves the sprinkler, it may not all actually hit where we're targeting for it to go. The wind can take it. And then the other place it can go is up. It can, through evapotranspiration, it can evaporate from the surfaces, and the plants are also transpiring. So how do these things change depending on the time of day? We've got a bunch of sensors out there. I like to say that we have made this field into a Frankenstein with how many sensors are out there. It's just fantastic. We're also measuring how often we're mowing the turf, what the quality of these flowers are, what the production is like. And so a lot of measurements are going on out in that field to really look at everything. The water balance that we just showed, and then also, are there any changes to microclimate too? So I'm just going to share results really briefly. And please keep in mind, this is extremely early on. We're still working through the results. But just to give a little teaser, so the first thing is looking at this water loss to wind drift and evaporation. So here I've got a graph with months. It goes by month, the percent water loss. So what percent of the sprinkler irrigation just drifts away in the wind? And the green bars are turf and the purple bars are zinnia, with the darker ones being at night and lighter bars being during the day. And so you can see for both crops, generally speaking, day tends to have greater wind drift losses, but there's a bunch of noise, right? Are these differences significant? We're still working on that. But generally there are greater wind losses during the day. And if we total up the averages across the entire season and look at the crop, the day versus night, you can see that it actually is really close. So unlike the studies, those were in Spain actually, that found bigger differences in wind drift losses, ours are relatively close. So that's the first thing. The second thing is this whole idea of microclimate, that if we're irrigating during the day, it's actually cooling things off for the plants, reducing stress and also reducing ET. So here I've got just the week that we're zoomed into with 3 irrigation timings. The black is night irrigation for turf and green is day irrigation. Bottom here are for our zinnias, dark red is night, and then orange is day. And so I just want to point out these little peaks here where you can see the temperature of the canopy of the plants that are watered at night is actually hotter during the day. And the reason for that is because when we're irrigating, when it's the hottest time of day, it's bringing the whole temperature of that canopy down. So the canopy temperature is cooler during the day with daytime irrigation. Night we see a drop too, but it's happening at night, which doesn't really matter so much to the plants. The other thing is looking at the humidity, and you can see that there's more humidity in the day irrigated plots. So that's going to reduce the evaporative demand. And so if we see how that then plays out in terms of looking at evapotranspiration, the competing process with wind drift and evaporative losses, this is work that we're still really working on. These calculations are not easy to do. And so Sammy's made a bunch of progress on this, but we're using different methods to calculate ET, and we also are modeling it through a soil physics program. And so just in focusing here on turf, Zinnia is showing similar results. There is a little bit more ET when we're watering at night. So daytime actually can reduce ET. Now, this is the last graph I want to show, and it's super exciting. But I understand it's super busy too, so stick with me here just for another second. Here we're looking at the soil moisture from the end of May into September, and I'm just showing turf here so we can zoom in a bit more. So all these little peaks are when we're irrigating. And so again, the daytime turf is green, and the turf that's irrigated at night is black. So you can see that the peaks are similar, so we're irrigating the same amount, but then check out this shoulder here. You can see that it falls much more gradually with daytime irrigation than it does at night. So it's showing that there's a lot more water being taken up by plants to transpire and things like that. So it's kind of backing up those ET results. So I don't think I quite have time to talk about yield, but I will just say that there really wasn't any difference for day versus night irrigation in either crop, turf or zinnia, for yield or quality. And so to summarize, we are measuring water losses from day versus night irrigation. It's a complex thing to do, lots of instruments, lots of calculations and models. And so this is certainly ongoing research. So just something to kind of start thinking about. And really what it looks like it's coming down to the most is when is the wind speed greatest in your area. Generally, it happens to be greater during the day, but potentially these reductions in ET can cancel out that wind drift since it's so close. But that remains to be seen. We're still analyzing that. And then again, there's no difference so far in the way these crops look or produce. And so with that, thank you all so much, and to our sponsors, as well as all of the people who are behind this project and helping make it happen. So thank you.
Thank you, Melanie. I very much appreciate this work. It's really interesting to me. And just a teeny bit of housekeeping I forgot to mention when I was introducing Melanie. If you have questions, please share those in the Q&A box, and I will moderate the questions after our first three presenters. So thanks again, Melanie. We'll have some questions for you shortly. And what I'd like to do now is introduce our next presenter. Candace Shively is a colleague of mine in the Center for Water Efficient Landscaping at USU. She's been leading and developing outreach and education programs for USU Extension in Iron County since 2008. And she focuses on urban agriculture and the home landscape with a large emphasis on water use and conservation. And she's going to share one of her more recent efforts with you now. Great. Welcome, Candace.
Thank you, Kelly. I appreciate that introduction. So I'm going to share a project that Jake Powell and I started working on in 2019. We got a grant from Utah State University's Water Initiative, and then we got some matching funds from a local builder to install a demonstration street within a new subdivision in Cedar City, Utah. Again, the project started in 2019. In 2020, we really focused on developing the website, and then now in 2021, this is our last year of funding. We're going to finish and hopefully get 6 to 8 more landscapes installed this summer. So I'm going to kick things off with just about a 3-minute kind of introduction video that gives you a little bit of a tour of the street as if you were there in person.
Last year, Jake Powell and I received a Utah Water Initiative grant to install a WaterWise demonstration street within a new development in Cedar City, Utah. So this idea stemmed from our WaterWise demonstration garden. The garden is beautiful, but it takes a lot of resources to maintain it, and it's hard for a homeowner to mentally downsize a demonstration garden and imagine it in their own yard. So the thought was to create a demonstration street with each of these front yards on the street, showcasing water smart principles and plant materials, and then creating outreach materials so homeowners can hopefully have everything that they need to recreate a similar space in their landscape. As an added bonus, we don't have to maintain the landscape, the homeowner does, but we are definitely here for support. And as an added bonus, we can turn the homeowners' frequently asked questions and any troubleshooting that they come across into outreach materials for other folks. Once we received funding, we partnered with the Iron County Home Builders Association, communicated our plan with them, and they matched us with a developer that was willing to work with us. Alex Meisner Construction has been amazing, and the best part is that they use the same landscape company for all of their homes. We have quite a few requirements, such as smart controllers, flow sensors, amending the soil, drip systems, digging plant holes 2 to 3 times wider than necessary, and many more. So working with one landscaper has really simplified things. Big Trees Nursery in Canaryville, Utah has been acquiring specific plants for us and providing them at a discount. And Donna Christensen with ERA Realty is helping us to recruit homeowners into the project. So this project is still fairly new. We are currently in the website development phase. We're working on some how-to videos to post to that website. We're trying to get the site plans up there and plant lists ready to go. And we're still recruiting participants. We're also starting to monitor water use. We really want to compare the traditional landscapes to our water-wise landscapes. And I'm really excited to see where this project goes. Thanks for watching.
Okay, so just a quick recap. We got about $75,000 from USU's Water Initiative, and then we got matching funds from the builder. And as any of you know, when you're writing grants, those matching funds are huge. Another source of the matching funds was we partnered with Big Trees Nursery down in Canaryville, and she's been really great at getting plants in that she doesn't typically get in for her clients, and then also giving us a discount on those plants. So that has helped a lot with reducing cost for the project. So I just wanted to show you a couple of the plans that we just finished for 2 of the homeowners that are hopefully getting installed this week or next. The first 3 landscapes that you saw were pretty heavy on the rock side. Those videos were also taken right after installation, so the plants aren't at that point in the video, just aren't mature yet. We're trying different things with all the homes that we're doing. So this next home, we worked with a homeowner over Zoom. I think we had about 4 meetings, and it took us about 3 weeks to really fine tune a landscape design that they were happy with. We're going to try some water-wise turf varieties. We have some rain garden areas closer to the street side and by the patio. So we're really trying to work with the direction of the water flow on this one. And then the same with the other client that we worked with. So I'm really excited to get these installed and include them in our video. Just a couple things that we're doing with each of the landscapes. We're using the Ranchio smart irrigation controllers, and we're also using the flow meters so we can monitor water usage on each of the sites. We also want to make sure that we use proper irrigation practices, and we're documenting everything with videos so we can make some great how-to videos for homeowners that'll be on the website. when we do a lawn, we're either doing subsurface drip irrigation, or we're using like the MP rotors, like the rotating spray nozzles that are just a bit more efficient. And then we're using water-wise plant material. And we're also spending a lot of time amending the soil. So the very first home that we did was for the Festival of Homes back in 2019. And I just wanted to quickly walk you through this process because it kind of ties over to every other landscape that we're doing. So some of the key things that we're doing are the soil amendments. We decided to work in almost like planting pods and amend sections of soil versus amending the entire site, especially for this landscape because the lot size was rather large. We're doing everything that can be on its own zone is on its own zone. We don't want the trees and the turf on the same irrigation zone. We don't want the shrubs and the perennials or the shrubs in the lawn on the same irrigation zone. And we definitely don't want if anyone has a garden, we don't want the garden on the same zone as some of the water-wise plants. So we're really taking the time to make sure we do things right and then also document and translate it into educational materials for the homeowner. On this particular lawn, we did do subsurface irrigation. So far, this is the only lawn with subsurface drip. The other two have the MP rotors. When we did the Festival of Homes, we set up a self-guided landscape tour, just kind of highlighting some of the elements in the landscape, and then set up a booth in the garage of the home that was manned by master gardeners to answer questions, hand out brochures, and then also we had a big board that kind of summarized in a little more detail the landscape tour that the homeowner or potential homeowner just took. So all of these elements here I'm showing you this because this is kind of going to translate to into our website in more of a fun interactive format. And I just want to give you a quick tour of the bones of our website.
These are kind of the bones of our website so far. There will be a map, so you could see the addresses and where the homes are located if you wanted to drive by. And then you could click on a site and see the site plans and the plant lists, and then also download. So we only have these 3 sites at the moment, and then there's kind of an about this project and where we're at and where we're going. There's going to be a blog, but the idea is that I could update things here. So like these site plans got uploaded and they'd be on that main blog page, which would then post to other things like social media. And then if I update water usage for the month for the sites, I would do it here, and then that would update within the site as well as different social media pages. So I think this will be a pretty neat spot for everything to be housed. These are kind of the bones.
And that is really kind of the summary of the project. I'm happy to take questions. Feel free to put them in the Q&A box, and we'll get to those. We'll get to those at the end.
Thank you, Candace. I'm really interested to see how this project evolves over time. It's a terrific example of the kind of work that we do here at USU Extension. It's my pleasure now to introduce our next speaker. Well, actually, 2 folks, if I may. We're going to have a video from my colleague, Dr. Yoshi Chikamoto, who's an assistant professor in the Plant, Soils, and Climate Department at Utah State University, and he's also affiliated with the Utah Climate Center. And his research focuses on Earth system forecasting with an emphasis on climate dynamics, atmosphere and ocean interactions, seasonal to decadal climate predictions, that is, Earth system modeling, and climate impacts on Earth system processes. So he has developed a video for us of this project that he conducted with several co-authors there, one of whom is Dr. Simon Wong, who studies climate variability and weather processes, as well as extreme events and climate predictions. His research has appeared in many scientific journals such as Nature Climate Change, Science, the Journal of Climate, and Geophysical Research Letters. He shared with me that in former lives, he was an Air Force weather officer and a freelance photographer, which is terrific. And he's going to be participating with us this morning during the Q&A session. And again, if you do have questions, please put those in the Q&A box, and we will get to those after this video presentation.
Hi everybody, thank you for watching this presentation. I'm Yoshi Chikamoto, Assistant Professor at Utah State University. Today I'm very excited to share our recent research, multi-year predictability of Colorado River water supply. Colorado River is an essential water resource in the Intermountain West, and drought is a primary concern, particularly in Utah. Let's see the blue line in the right panel, which is a historical record of Colorado River water supply estimated from natural stream flow at Lee's Ferry, Arizona. And this left panel shows the correlation of this time series with soil water anomalies. And we can see green area in the southwest. So these results indicate a shortage of Colorado River water supply accompanies dry soil conditions across the southwest, as seen in these green line colors. And when we take a regional average of soil water anomalies in this black box region, its temporal variability follows the Colorado River supply very well, as shown in this black dotted line. So the Colorado River water supply is a good indicator for drought events. And the drought causes a severe damage to agriculture and forestry. The upper panel shows the probability distribution of soil water, crop yield, and wildfire intensity during the water shortage years in the red color compared to the all years in gray colors. The severe water shortage years come from the yellow shade in this time series plot. And during the water shortage years, we experience drier soil conditions, crop failure, and intense wildfire activity. So we can assess future agricultural losses and forest damages by predicting Colorado River water supply for the next year in advance. But the question remains, how can we predict it for such long period? Generally speaking, weather forecasts are reliable only for a couple of days, and multi-year predictions sounds really challenging. And we will overcome this challenge by utilizing the global climate model and long-term ocean memory. Okay, this picture shows a schematic view of our model experiment. We use a global climate model named Community Earth System Model, which consists of 4 components: atmosphere, ocean, sea ice, and land. Those 4 components are interacting each other. And in this model, we prescribe radiative forcing, such as atmospheric CO2 concentration. And the model also incorporates observed ocean information into the climate model, which is called Ocean Data Assimilation Lab. And this is our unique approach. Then we conducted the predictions initialized on January 1st every year. This procedure is the same with the weather forecasting, and we refer to it as a hindcaster. A more detail of this experiment can be found in this paper. Okay, let's check the performance of our approach. So this slide, as I showed before, and this black line is a model simulation in the Colorado River water supply, which is estimated from the regional average of model simulated soil water anomalies. And our model includes observed ocean information, but there's no atmospheric observation and no land observations. Nevertheless, our model simulates observed water supply variability very well, particularly in multi-year drought events. So in other words, multi-year water shortage arises from long-term ocean memory. Okay, let's check our predictive skills. So this is the same one, Colorado River water supply in the black line, and blue line is a climate change component. And in this case, climate change component is much more smaller compared to low frequency variability. And this red circle shows a hindcast experiment for 1 year lead time. And we can see this red circle follows the black line very well, indicating high predictive skills in our model. And the red color in the right panel is a predictive skill metric of how long the Colorado River water supply is predictable in our model. I skipped the details, but this figure indicates Colorado River water supply is predictable for several years in advance because of the long-term ocean memory. Yet we still don't know what kind of ocean variability contributes to the Colorado River water supply multi-year predictability. So we trace back the ocean precursors which causes a water shortage. This figure shows the sea surface temperature anomalies before the water shortage. And we can find La Nina-like sea surface temperature cooling 1 year ago. But if you go to the 2 years before, we can find North Pacific temperature warming. And if we go back to the 3 years ago, we can find tropical Atlantic warming. So these SST sea surface temperature anomalies would serve as the ocean precursors for the water shortage. This is a summary, and we found 3 ocean precursors: tropical Pacific, North Pacific, and tropical Atlantic. To validate these ocean precursors, we developed the oceanic indicator for Colorado River water shortage using a multi-regressive technique like this equation. So if we monitor these 3 ocean variability, we can predict future water shortage. And this is our result. So red lines are ocean indicators for Colorado River water shortage estimated from 2 different datasets, COVE-SST and NOAA SST, overlaying with observed water supply in this blue line. When the ocean indicator below -1, we can always observe shortage of the Colorado River water supply. Of course, some shortage years are not predictable in our approach, which relies mainly on atmospheric randomness. But our oceanic indicator represents multi-year drought probability, and we can use it as an early warning of prolonged drought events. And this forecast will be available in the Utah Climate Center webpage. And this is the most updated prediction. So now in the south of Utah have a severe drought conditions, but ocean indicators show getting that wet conditions. So we hope drought in the south will finish within a couple of years. Okay, thank you for your attention, and please check our manuscript published in the new Nature Journal, Communications, Earth and Environment. Also, please feel free to contact me anytime if you have questions and comments. Bye.
Thank you, Yoshi. We may have him joining us here. Oh, we do have him joining us here. Thank you, Yoshi, for your presentation. And perhaps you and Simon can join in the Q&A. I do have a couple of questions to share, and I will start with Melanie. The first question is, does the cooling effect of the microclimate and ET rate when irrigating during the day differ significantly depending on method of irrigation?
Wow, that's a great question. And it's not something that we are testing specifically in this study, but if I'm thinking about other types of irrigation, especially in an urban setting, I would think of drip irrigation or flood irrigation. And I don't think you would get that same kind of microclimate cooling as you do with sprinkler, where the water is coming through the air, the droplets are going in the air, it's getting hung up in the plant canopy as well. Whereas with drip, it's so efficient, it's just right at the surface, so you're not getting that mixing with the air. And then similarly for flood irrigation, there's definitely going to be some evaporation happening while you're flooding, but I don't think you would have that same kind of humidity with what happens when there's droplets in the air. So, great question.
Great, thank you. Candace, let's ask a question to you. Are you seeing acceptable distribution uniformity with the Hunter MP rotators? And also, what is the smallest area, I think they mean, of grass that can be efficiently irrigated with spray heads? Excellent project and presentation.
Good question. Yes, the Hunter MP rotors are currently, I don't know if I'm allowed to say this, but currently they're my favorite. We're also trying out the Rainbird R vans and struggling with those a bit. I feel like there's just a lot of small components in there that are getting plugged up and clogged, and I'm replacing those a lot more than I'm replacing the Hunter brand. As far as size, I'm going to give my answer and then let Kelly follow up because she's definitely the expert on that. Now I'm getting nervous. I believe it's 8 feet. That we're not doing any lawns with less than an 8-foot spread for spray irrigation.
Yeah, that's a good rule of thumb right there, I would say. But I think one thing with turf grass, and I don't want to get too far into the weeds on this, but we're really looking more, especially in certain climates in Utah, at drip irrigation for turf, which I think can be a fantastic solution for small turf areas and also to minimize evapotranspiration. But yes, I agree with the 8-foot recommendation there, Candace. Let's move on. I have a question for Simon and Yoshi. And that is, and I think it might have been in one of the slides, but it went by pretty quickly. And I'm just wondering if you could describe for the purposes of your project, how you're defining water shortage.
I think I can chime in here. This is Simon. Defining water shortages really depends on where you come from, right? And what kind of the size of the farm or the size of the watershed you manage. So we looking down from like 30,000 feet, from a larger scale and Earth system perspective, we define water shortages being something that is prolonged. So if you look at the Colorado River time series and the one that we show, that Yoshi showed, that came from actually the Bureau of Reclamation report. And that's really not the year-to-year variability, because in the report, they already provide a 10-year running average, which means that in the mind of most of the water managers in the West, it's the back-to-back drought and the back-to-back water shortage that is most concerning. And so that was our focus. And so from the Earth system perspective, the climate perspective, anything that has the memory or has something like this cyclical behavior and also a prolonged duration, usually they come from some signals that is hidden in the soil and also in ocean systems. And as Yoshi has shown, that he can identify these ocean signals, and then we provide those diagnostic analysis to understand those are not just random, not just coincidence, but they come from a series of mechanisms, ocean interacting with the atmosphere, and the atmosphere, then interacting with the land. And then that leads to these 2 to 3 years of memory that we can use to track, either how soon we can come out of a bad drought or whether or not the next prolonged drought is approaching. That help?
Yeah. Thank you, Simon.
Thank you.
I have a question for Melanie, and then I have a question in the Q&A for Candace. Melanie, I know you were limited on time, but you did just briefly mention that you had a little bit of data on the zinnia yield, and I wonder if you could maybe just do a quick summary of that for the audience as it relates to the project so far?
Yeah, sure. So we're looking at yield, and we're also looking at quality of things. And so for zinnias, we actually we were cutting them 1 to 3 times per week and measuring their quality. And we also grade them according to florist standards, because you can actually sell zinnias for $1 a piece to florists. So anyway, we were looking at marketable ones that were perfectly formed and had at least a 1 foot stem length, and then also everything that didn't quite make the cut. And so in terms of the total yield, doesn't matter quality, they both were producing around 11 or 12 stems per square foot, pretty good. But then in terms of marketable stems, so high enough quality, they each produced 3 stems per square foot. So there really wasn't a difference that way. And then with turf, we were wondering if one of our, so say daytime irrigation is less efficient, maybe that would mean that the turf isn't growing as well, and maybe we wouldn't have to mow it as often, and maybe that would be a benefit for homeowners. But unfortunately, we found that no, we still have to mow just as often. We measured the clippings too to just see if there was more from one irrigation treatment or the other, and there really wasn't. And then similarly with the turf quality ratings, we were taking pictures every week of the plots and then analyzing them for percent cover and also their greenness index. And again, we didn't see a difference. So.
All right.
Yeah.
Thank you. Candace, this question is for you. Are you using stormwater distribution for any of your demonstration landscapes?
Yes, the 2 new landscapes that are hopefully being installed this week and next week, they'll both have rainwater basins to collect runoff from the roof.
Okay.
Good question.
Yeah. Okay. Let me see here. I had a question for Candace as well. I'm just curious, and hopefully the audience is curious as well. How have you seen interest changing as you've been working through the project? I mean, I suspect this was all new news to many folks, but as the project has gone on, are you seeing more interest and more inquiries from homeowners?
Yes. When we first started the project, it was a little difficult to get homeowners recruited, just because there's a lot of people to communicate with before you actually get to the homeowner. So that was kind of a challenge I didn't really anticipate having, but it's just kind of shows the beauty of repetition. So the more we talk to the real estate agent, the more we talk to the landscaper, and the more homeowners that are participating, it's kind of snowballing. So I'm really hopeful that we'll be able to spend all of our money this year.
Great. And one more question. I believe this one is, no, I think this one is for Melanie. Okay. Has the organic matter content of your soils, I'm assuming, been measured and compared in your trials?
Wow, that's a really neat question, and it really kind of gets at potentially like root production, right? And it's what it's adding to the organic matter, if it's more or less between the timings. So we did not measure organic matter. We are doing soil testing every year, more for nutrient management of the crops, and also keeping an eye on pH and salinity. We haven't done organic matter. Organic matter is something that just changes so slowly, though. It's a really tough one to really build up unless you're purposefully trying to do it with mulches and things like that. But we do have some baseline levels from the farm. And so it wouldn't be difficult to just do a test and see where we're at. And I think it'd be actually really neat to do at the end of this year, because then we'll have been in 2.5 years of this special timing. So thanks for the great idea. I would say that I think it's worth checking out, but it is hard to build up organic matter significantly. So I don't know that we would see a difference, but I think it's a cool idea for sure.
If I could follow on from that, Melanie, just quickly,
Sure.
I know you mentioned that you're measuring yield for the grass clippings, but is that a periodic measurement, or are you routinely returning grass clippings?
We are not returning the grass clippings. Yeah. Okay. Oh, not good.
Let's discuss. Let's discuss.
Yeah.
Maybe I'll wrap it up with just one last question for Simon, and as it relates to the river modeling project. And I know that in Yoshi's presentation, he mentioned, or showed, I should say, that the supply was predictable for, I believe, about 5 years. And I'm wondering if there's ongoing work in the project, and specifically ongoing work to extend those predictions beyond 5 years.
The to extend it is really at the mercy of Mother Nature. I mean, in those cases, this happened that we could trace and then confirm the ocean part of the forcing. But then, when it goes to like 5 years, then you start to get tricky because, you look at this 10 years running average water supply data. It doesn't really represent year to year, so forecasting for like next year or the coming year, I mean, it's always also a great chance to miss it. But so the tendency is the key. I mean, the upturn, the downturn, the duration is really the key. So yes, we are trying to develop it and then the next phase, it's a half science and then more and the other half communication, really translating it to what will matter the most or more directly to users. So that, believe it or not, is actually harder than building a model, I think.
Interesting. Thank you for that. Well, I don't see other questions in the Q&A, and I do believe that we are going to leave a bit of a break in between this and our next panel. But I would like to take this opportunity to thank our presenters, Melanie, Candace, Simon, and Yoshi, wholeheartedly for your participation and your willingness to answer questions and be part of our conference. And so now, and Candace, please correct me if I'm wrong, but we'll take a little bit of a break and get started again at 11 with our next panel. So thank you very much, panel. I appreciate you.
Thank you.
All right, let's start our gray water session. For those of you that are just joining us, welcome to the second session of our Utah Water Conservation Forum Spring Conference. I'm Candace Shibley with Utah State University and the Center for Water Efficient Landscaping. And today I'm very grateful that Orion Rogers and Rosalind Breen McCann are joining us today. We are going to kick things off with Orion covering some policy things, and then we'll turn it over to Rosalind, and she's going to cover the residential and commercial and kind of the how-to, and then we'll open it up for a panel discussion. So if you have questions as we go along, type those into the Q&A box at any point, and then we will we'll get to those during the panel discussion. Orion is from a blink of an eye town in southeast Utah called Thompson Springs, where the dog population outnumbers the human population. He attended the University of Utah, where he earned a BS and an MS in geology, after which he moved to Louisiana and worked in the oil fields. Upon realizing that working on an oil rig was loud, lonely, and generally not fun, he took a position as a geoarchaeologist, or with a geoarchaeologist firm, assisting in archaeological site assessments and impact studies. In early 2013, his dad snail-mailed him a newspaper clipping advertising a position for an environmental health scientist with the Southeast Utah Health Department in Moab. After looking up what the heck an environmental health scientist was, he applied for the position and got the job. Since then, he has worked in the areas of environmental health and has been promoted to the position of environmental health director. Specific to gray water, Orion oversaw the installation of the first legal branched drain gray water system in Utah, and played a really big role in the drafting of an amended gray water code, which made the installation of gray water legal in the state of Utah.
Awesome, thank you. Is my share screen visible? Okay, so we're good. All right. So as I just mentioned, my name is Ryan Rogers. I'm the Environmental Health Director for the Southeast Utah Health Department, and have played an integral role in getting gray water towards even a reasonable possibility in the state of Utah. As was mentioned, I helped rewrite the state gray water rule. The previous rule essentially was useless, and was written in such a way to make it so hard to do gray water that nobody ever bothered trying to get a permit or trying to do it. So kind of the history of what happened to get this new rule, R317-401, was Roz came to me and told me that she wanted to install a gray water system at her new home that she was building. I had just recently finished taking on-site wastewater certification courses, which are the certifications required to be able to design on-site wastewater systems, so septic systems and whatnot. But gray water is lumped in with that. So Roz comes to me and says she wants to do a gray water system. I tell her that I just went through the training courses and gray water was silly and there was no point in doing it. And she brought this idea of a branch drain system to me, and it changed my mind, essentially. She, in conjunction with Jeff Adams, who also is a big proponent for gray water, so they proposed this newfangled idea that really wasn't newfangled at all. They're doing it in other states for a long time, and talked me into it. And so I was able to permit her system to be installed as an experimental system, because in state rule it allows for the installation of experimental on-site wastewater systems where an alternative means of disposal is available. So long story short, we get that system installed, monitor it for a little while, and just make a few changes because we learned a few things. But after I became confident in that system, I was able to take it to what is known as CALPE. It's a great name, which is the Committee for On-Site Wastewater Professionals, and brought it to the group, suggested changing the current gray water rule to something that was useful. And we then formed a subgroup of that, of CALPE, to start rewriting the rule in conjunction with the Division of Environmental Quality's Division of Water Quality section. And so that rule writing process began, and 5 or 6 years go by, because it apparently takes time to rewrite state rules and whatnot. And I kept telling Roz every year, oh, it should be done by Christmas. And it was a lot of Christmases that I told her that. But anyway, the rule ultimately finally gets rewritten. It goes back and forth. It has to go to all the environmental health directors like myself, the 13 health departments in the state, for them to all agree that it was a good thing to have go through. It then has to go up to the health officers, which are our bosses. And then beyond that, it has to go to the state water quality board, which is made up of a number of people that play different roles throughout the state. And that board was able to then vote to adopt the rule as written, and have it go through the rule writing process. After it goes through the rule writing process, which was essentially them editing what we had written, it was finally able to be voted upon to be adopted as a rule, and it was enacted on March 26, 2020. Since then, there hasn't been a lot of gray water things happening because health departments have been a little bit busy for the last year dealing with COVID. So anyway, but now it seems like things are ramping up a little bit. So one thing that wasn't ideal is that originally we were hoping to write the rule in such a way as such a way that health departments would have to opt out of administering the rule. So in other words, all the health departments were supposed to administer this rule unless they chose to send a letter to the Division of Water Quality saying that they didn't want to administer the rule. Because of staffing issues and that sort of thing, there's a little bit of pushback on that because some health departments didn't feel like they could reasonably administer this rule. and didn't want the image to be out there that they were opting out of water conservation, and that wasn't the case. So the rule got changed, the rule got written to where health departments had to opt in. So, and it's really not that it's not very hard. Pretty much we just send a letter to the Division of Water Quality saying that we have all of these things. It's literally in the rule. We have adequate staff to be able to do it. We have the technical capability. The local Board of Health supports it. In our counties or jurisdictions, legal authority to implement the program. So pretty much we had to just say, we can do this. We have the people to do it. We have the expertise, the certifications, all of that. And so, surprisingly enough, I was the first person to send this letter, and the first health department to get approved for administering this rule. So, but along with, and there are other health departments that opted in, and I'll get to that here in a little bit. But one of the things that, so I guess to emphasize, it's not just the health department that are the ones that need to know about these gray water systems and how to do it. It's very important to work with all of our partnering agencies. So the Board of Health, that's obviously important because they oversee what health departments do and make sure that we're in line, essentially. And then the building department's really important too, because we have to educate our building department about these gray water systems. Gray water systems are included in international building codes. However, those codes are pretty similar. They're pretty similar to what we moved away from in the old rule. And so partnering with the building department helps to make sure that the plumbing on the inside of the home is installed correctly and to code for them. And it kind of forces things to get mixed up a little bit. Like homes aren't plumbed the same way as they have been in the past if you're going to do gray water. So making sure the building department knows what's going on is great. Also working with your planning and zoning department so that they know what's going on as well, your local elected officials. Then the builders and developers, like if we don't make it known that these systems are even possible or legal, the builders and developers aren't going to install them. So once we bring it to our builders and developers, make sure that they know, they come and apply for a permit and say, hey, I want to do the subdivision. And you say, hey, then we as the health department or the building department, whoever, or sustainability directors in our area, so on and so forth, if they then were able to then promote this, the installation of the gray water systems at that time of application, which a lot of builders are pretty excited about trying to do these more sustainable practices, and other ones aren't, but that's just the way it is. So partnering agencies are important. That's the point there. Local interest. So this is this picture is of some straw bale homes that are installed throughout the Grand County area by a developer called Community Rebuilds. They build homes for lower income folks that are highly sustainable, with straw bale construction, solar, so on and so forth. For quite a while now, this group has been stubbing out homes. So they've been installing the gray water plumbing inside, waiting for this rule to come into effect. So we're slowly trying to get these systems installed on the outside of the home and permitted as the health department for these homes. Our housing authority also has been stubbing out homes and has interest as well. So there's seems to be a little bit more interest in the Grand County area than other outlying areas. And I think that a lot of that just has to do with it. It's talked about more here, and we have developers that are promoting it. The slides changed a little bit. Anyway, so results. Roz is going to show some more pictures of these. But this is Roz's house, and it turns out the gray water isn't silly, and you can do cool things with it. And this is a before and after picture of her house, and it really shows that you can make a beautiful garden using just the gray water out of your home. And it's and Roz can correct me, but I believe that she's using only gray water at this point to sustain her front foliage.
Yeah, that's right.
Yeah, and she'll talk more about all the cool plants she put in there because I don't remember them all. All right, so the future. This is not even the future anymore. So this is a big development called the Arroyo Crossing that's going in Moab. The property is owned as a land trust, and so essentially the land is owned in trust. I don't know how all that legal end of things goes. It has a board that oversees it, and each of these lots is then in some way that it's like a 100-year lease or something to the property owner or to the homeowner. So that community rebuilds that I mentioned before, as well as the housing authority, are going to be building affordable homes on each of these lots. This is just the first phase that you see here. I believe there's close to 300 lots, and within the trust, it doesn't require gray water use, but it highly encourages it to the point that if you want to have any form of turf at all, you're required to install a gray water system. But then there's other complications that happen, such as the lots are really small, which makes it hard to install a gray water system on them. And the geotech reports says that the soils don't like water. So we're working through this right now. But ideally, we'll at least get the majority of these lots built with gray water and rainwater catchment sort of landscape. Obviously, there'll need to be some supplement because you can't get gray water to all parts of your lot necessarily, and you have to meet certain setbacks and things like that. But essentially, it's exciting. It's happening. One of my employees actually is going to be building one of these homes. She's super excited about it. I helped her design her landscape plan yesterday for her first home. So that's kind of the future. We hope to see it going further. There have been discussions both with the Grant County administration as well as Moab City administration about having certain requirements for gray water installation, and potentially, and I hope that maybe at some point we'll be able to require at least the installation of the infrastructure within the home for gray water for any new builds, because it's really difficult to retrofit most homes to be gray water capable. So who's opted in so far? Southeast, that's me and my team. Central Utah has opted in. They haven't seen too much interest yet. And Weaver Morgan Health Department has also opted in. And it's my understanding that Summit County's health department is preparing to bring the idea of opting into their Board of Health. So, and there's a few others that are thinking about it. So it's a start, and we've got a little ways to go. And I guess that's kind of the end of it for me. Roz will go into her presentation. I might jump in a little bit on some of the, we were hoping to have Jeff Adams in on this presentation, but he was unable to attend. And so if we need to talk about the design and whatnot, I can help with that as we go. So thank you.
That was great. Thank you so much, Orion. Rosalind, I have to set up a tour of that subdivision. That sounds amazing. All right, next we're going to turn it over to Rosalind McCann. She is an associate professor in sustainable communities with the Department of Environment and Society in the College of Natural Resources at Utah State University. She houses the first legal residential gray water system in the state, assisted with updating the state gray water policy, is a certified water harvesting practitioner from the Watershed Management Group, and co-authored the extension fact sheet about gray water systems. So with that, I will turn it over to you.
Great. Can you hear me okay?
Yeah, you sound great.
Okay, fantastic. Yeah, and by assisting in writing the code, really, that's a polite way of my writing that I was a squeaky wheel and pressured Orion to help me with this, and he did an amazing job with the policy technical details. Not my strong house as a social scientist, but was really excited about helping move that forward. So my work in this really stemmed from 2014. I attended a watershed management group professional development training in Albuquerque to become a water harvesting practitioner. And that was an intensive multi-day training and involved a lot of math and installing of different systems, including a rain tank. And one of the systems we installed was a branch drain gray water system. As Orion alluded to, I was right in the middle at that point of building my own house in Mulberry Grove in Moab. And this is a picture of the gray water system 2 summers ago. And as he mentioned, now this system is entirely just growing off of the gray water that we are feeding into the system from our bathtub and shower and laundry. And in this picture, I'll just explain real quick. You'll see several different flowers. A couple I'll highlight are the echinacea, their medicinal plant that is a great native bee attractor as well. And Russian sage does really well with minimal water, so that's planted a little higher up in the gray water system, more on the edge and outside. And I think it's important to think as you're planting in a gray water system to put your more water intensive plants lower down in the elevation and your less higher up. And then the tree you see in the top corner there, that is peach, and behind the peach is a Utah giant cherry that's also growing in this basin. I have another basin on the other side of the house that I think you saw in a picture that Orion had shared that has a Lapin's cherry and a nectarine as well, and several other understory plants. And so I'm a big advocate for very diversified landscape. My kids love it. I have a currant growing in this gray water system that my son just loves to eat the currants from. And I really feel that if we're feeding water into a system, we should be getting multiple benefits out, whether that's beautiful flowers to look at and bees to observe, or fruit to harvest and use in the kitchen, herbs to harvest and use. And the kids really seem to gain more from a landscape like this than a monoplanted landscape as well. And so going back to that water harvesting practitioner course, learned about branch drain systems, came back extremely excited as I was building my home. I realized when I got back to Utah that the code in Utah was very different than the code in New Mexico and in Arizona, and much more prohibitive, as Orion alluded to. And worked with him, and he was extremely incredible to work with in understanding and also advocating now for changing the policy and realizing the potential of these more simple systems and cost-effective systems. Moab has a large population that is low income, and so a system that is very inexpensive is also appealing from that angle as well. And so we worked to get this system installed as a pilot, as he mentioned, in July of 2016. We went ahead and finalized, and I got the first legal gray water permit in the state for this landscape. And so let me go through some of the basics today with you all. I have 3 objectives for the next few minutes we'll have together. One is to, by the time we're done, if you don't already have a clear definition of gray water, at least for the state of Utah, that you'll have that, and also its potential at the residential level. Observe system examples, and then describe the anatomy of residential gray water systems and what these actually look like as they're being installed. Okay, so let's start with gray water, then we'll go through a couple other key terms as well to make sure we're all on the same page. So the Utah Office of Administrative Rules defines gray water as wastewater from bathtubs, showers, bathroom wash basins, clothes washing machines, or laundry tubs. Gray water does not include wastewater from toilets, kitchen sinks, photo lab sinks, dishwashers, water softeners, garage floor drains, or other sources that pose a public health hazard. So that's a very basic definition of gray water for you, just to know what's allowed here in the state of Utah. Okay, so clear water is another term that you might hear now and then in this realm. Clear water includes water produced while waiting for your faucet to heat up, for example. So it's captured potentially in a pot and used to water plants. That's what we do with our clear water, or we refill our bird bath. That's a great use for clear water in your kitchen. We have a pot right behind the kitchen sink that we use to fill up and water our plants or indoor plants, or refill the bird bath. It can also be collected from your refrigerator compressor drip and swamp cooler and air conditioning sweat. So that's clear water. Black water includes your toilet water, but in Utah, kitchen sink and dishwasher water are also categorized as black water due to their increased likelihood of E. coli presence. I clarify that in Utah because some states call kitchen sink and dishwasher or dishwasher water dark gray water, or they just term that differently than in the state of Utah, but our state considers that black water. The EPA defines stormwater as rainwater or melted snow that runs off streets, lawns, or other sites. As stated by the Utah Department of Environmental Quality, stormwater runoff from homes, city streets, parking lots, industrial facilities, and construction sites are often contain sediment, fertilizer, pesticides, oil, gasoline, pet waste, or hazardous waste. And because stormwater isn't treated, the runoff that you see flowing into the storm drain is discharged directly into nearby water bodies along with any pollutants it contains. This definition, I think, is really important to think about as we look at the larger picture of why we're doing what we're doing. Of course, we are in a water emergency in the state of Utah right now, but really we aren't treating rainwater and water flowing on our landscapes naturally as an asset. We generally tend to treat this as a nuisance, and that stormwater definition is a perfect example of that. When we're pushing rainwater away as quickly as possible on impervious surfaces, it picks up many pollutants and becomes a nuisance when it could become it could be used as a large potential that we aren't tapping into well enough in our state. So a bit of a plug for a paradigm shift in the state of Utah there. And with that, I'll define rainwater. So rainwater is defined as water fallen as rain that has not collected soluble matter from soil and is therefore soft. So now that we're clear on our terms, you may be wondering why gray water. So we'll begin this journey with a quote, and I'll give you a minute to read it. Okay, so gray water is one way to achieve higher resource abundance in light of forecasted hotter, drier weather in the Southwest, where we happen to have some of the highest per capita residential water use as a result of high landscape irrigation rates. According to the Utah Geological Survey, irrigation counts for about 72% of Utah's water use, and 50 to 60% of average residential indoor water use could become potential gray water sources. That's a huge amount, 50 to 60% that we're using in our household, we could be instead using to water plants in our landscape. So some advantages of gray water systems include effective water treatment. So gray water is treated in the uppermost biologically active region of your soil, and nature does a great job at that. Reduced use of ground and surface water resources for landscape irrigation, reduced use of energy and chemicals for water and wastewater treatment, improved plant growth, reclamation of nutrients, also wastewater disposal in rivers and oceans is of course a significant form of pollution. So we're decreasing some of that storm surge by infiltrating that into our landscapes. Increased awareness of natural cycles and personal water use, and also a landscape irrigation source in preparation for potential future drought irrigation restrictions. So things we might be seeing coming down the line as we continue to experience drought in our state. And so just a precursor as I go through some of these future slides, some of them are pulled from my own information and some of them from Jeff Adams. As Orion said, he unfortunately couldn't be here today, but Jeff Adams works with Terra Sophia here in Moab. It's an ecological design company, and he was an instructor at my water harvesting certification course in Albuquerque. I brought him to Moab I was showing him some of the permaculture projects happening around our town, ecological landscaping occurring in the Moab area, and he got pulled into a project and hasn't really left since then. So excited to have him here, and he has pulled together with me some of these slides, although he couldn't attend. Okay, so let's talk about household fixtures. So here's the percentage on average of water from different household features or fixtures that you commonly use. So here we see the potential of gray water systems. So if we combine the shower and baths as one, this is our highest potential, accounting for 23% of our indoor water use, or 31.3 gallons per household per day. So for those of you who have guessed, in looking at these, yes, the bath shower is our highest potential. Laundry, of course, is also an important and easy thing to pull from as well. 16% there, 22 gallons. Okay, so the faucet is generalized in this picture, so that would include bathroom and kitchen, and so we'll go ahead and discount it. So, but with that omitted, our shower, clothes washer, and bath account for at least 39% of our indoor water use, or 53.3 gallons per household per day. And so you could potentially be pulling quite a bit of water out into your landscape, especially if you're like me and have 2 little boys that tend to need a bath most evenings. At least my bath water is now growing cherries and nectarines and peaches. And my trees are very filled this year with baby fruit. I'm excited for that. Okay, so Orion talked some about our gray water code, and this is where I'm probably going to be calling him for some help. As I mentioned, this is not my wheelhouse. I'm a social scientist. I study human behavior, but I also, as part of that, a big part of my job is pulling the teams together to make change happen. And as I mentioned, Orion and Jeff are integral players in that. So the new code involves a couple key changes. One is this tier 1 versus tier 2 systems. And the main thing I just want to share in our short time together is that tier 1 is for residential only, and tier 2 is multifamily and commercial. And Orion, did you want to add anything about the difference between the tier 1 and tier 2 systems?
Yeah, so the tier 1 and the tier 2 systems, you can do, I always get them mixed up which one's which, but one is the simple systems, one's the more complicated systems. And you can install a more complicated system with tanks and pumps and all that kind of stuff on a residential. But in general, in a commercial setting, the simple systems just aren't going to work.
Yeah. Yeah, that's a great synopsis. Is tier 1 is simpler, smaller scale residential, gravity fed, like my system at my residence. And yeah, so it allows gravity fed distribution directly into your mulch landscape areas, which are also called a branch drain. I'll show you a picture of that here in a second. And it's really important to size your fixture, or size by your fixture or by your entire house. You're sizing your outlets, not just the outlets, but the actual earthworks correctly, so that you're able to infiltrate that into your soil in a event of having a lot of bath water, while also there's a heavy rain event occurring coming into the landscape, for example. So with that, the design considerations to think about, one thing I'll mention is to make sure you label your pipes. So non-potable water is labeled purple, so you want to either spray paint your pipes purple or have some sort of a labeling system so it's clear that that is non-potable water. And think about the setbacks from your house. That's a consideration in the code. To make sure you're sizing that area based on what type of texture your soil has or is, and the number of bedrooms in your house, and the number of fixtures that you're pulling from. And your system design, things you need to consider in that is a way to divert to your sewer or septic. I use a Jandy valve, it's called. It's a 3-way valve, and I'll show you a photo. Your pipe size and your slope. So my slope in my basins is a 2% grade, and the number of outlets, mulch shields, and your air gap. The air gap is where your pipe is coming out, and the drop for that before the water hits the ground underneath that mulch shield. The reason you want to drop is so that roots and other bugs and that can't get up into your pipes very easily. And so that gap is super helpful to have. And depth of cover of 6 inches. And so that can be mulch or whatever you're having cover your outlet 6-inch depth. Best management practices include no human contact. So you wouldn't want to be splashing around playing in your gray water. It needs to be infiltrating into the soil very quickly. No ponding with that as well. There's several, of course, health issues with if that water was ponding and sitting still. That's when you will be growing E. coli and turning that gray water into black water. You don't want that gray water to be running off into other sites, and spraying as well is a best management practice. So you don't want to be contaminating that with sprays, and contact with edible portions of plants. So what research in California has found is that woody stem plants have not taken any of the heavy metals. I'm forgetting the term for that, but into the fruit, but leafy green stems actually are a lot more porous and you'll have that soapy taste, etc. If you're having kale grown in your gray water system, not a best management practice. You'll want to instead focus on edibles that have a woody stem, and also obviously not including biologically or chemically hazardous materials in those drains. So if you're running a heavy bleach load in your washing machine, turn that Jandy valve to sewer and then turn it back to landscape when you're done doing that, or just don't use bleach at all if you're like me. And now with having toddlers and all the stains on their clothing, everything, I don't have any white clothing anymore, it's all gray. Okay, so your site context, things to consider, integrating that with your other landscape features and uses. So definitely looking at what's available to you and how to integrate the features on your landscape. And with that, the elevations and grading of your system are extremely important. So that comes with making sure that you can infiltrate that water effectively and that ponding doesn't occur. But also thinking about the plants that you're planting at different elevations and making sure that it's the right plant for the right place. Different water sources that are coming into play. So if you're taking in street side runoff through curb cuts and indented basins, of course, you'll have big surges during rain events. But if your system like mine on the north side of my house is my roof runoff in a rain event, I don't have a gutter on the north side of the house. It comes off in a heavy flow where two of the seams of my roof come together, and that goes into the gray water as well. So we had to take that into account when sizing our basins. And also, I already mentioned the plant water needs. So this is a laser level that Jeff uses as he installs gray water systems in and around Moab. This is a photo of a branch drain, and I know Jeff or Ryan probably wants to clarify that these outlets, the mulch shields here are too small for what we would like to have and what's in the code. And Ryan, please clarify this, but we started off my system with these smaller mulch shields and have found that they tend to clog too quickly. So, if you go more than a year without checking that and working to make sure that there's no hairs and stuff in your system, it does tend to clog more easily than a larger mulch shield. And I'll show you a picture of that as well. So Ryan, do you want to add anything with those outlets?
Yeah, the other benefit of having a larger mulch shield is it accounts for a surge capacity. So if the bathtub gets dumped and and somebody's taking a shower and so on and so forth, there's volume within those mulch shields to be able to hold the water until such time as it's able to percolate into the mulch is another big part of that. So we put it in the code to where those are a minimum of a 5-gallon capacity each.
Okay, thank you. Wow, this time is flying by. It always happens when I talk about gray water. So just a picture of a branch drain to show you what that looks like, the pipe size, and then the grading is generally around a 2% grade. That's a picture of a Jandy valve, like I mentioned, that the inlet pipe is, in my house, is that top pipe there, and then the two coming out each side. The one on the right in my house drops down to sewer, and the one on the left goes out to the landscape. And then that's a picture of the box in my house as we're building it that you can just lift up and turn that Jandy valve the other direction if you need to. And important consideration is when you have a flow splitter like this to be able to access that. So that cap there, I believe that's mine as well at my house. So that cap you can pull out, and where you have a flow splitter is likely where hair and stuff can accumulate over time. And so you can get in there and pull it out. I have long hair, so that's a place where you could have a blockage over time, and you might as well just build that system being able to access that easily like I can in mine. Those are the pipes coming out when we first installed this with these smaller mulch shields. And so these pipes we spray painted purple, as you can see, and then we're checking the grade to make sure it's set at a 2%, that the pipes are level, because I wanted equal water to go to my cherry tree as to my peach tree as well. Here's pictures of earthworks for another system installed at a community rebuilds house here in Moab. And this was a Jeff Adams install in his pictures here. And here's a picture of that all covered up with that 6-inch layer. And then here's a picture of my original installment there and the originally sized mulch shield, and that pulling out into the landscape underneath through an additional pipe system. But that pipe is very short. It's not very long. It's just to make sure that water is flowing from then that container out into the soil and the roots of the surrounding plants. So this is my house as it's being built, and Jeff helped me with the earthworks here as well. And so you have your basin layer, your bench layer, and your upland, and to make sure you're planting accordingly so that your roots will be able to access enough water. So more water intensive plants lower, smaller plants on the bench layers where I've planted my trees, and then the upland, more drought tolerant plants like lavender, some echinaceas do really well there, and salvias, etc. There's a picture of the system probably a year or two ago. So this is the Lappin's cherry. This is looking west and southwest, and just to show all that's growing now on our shower laundry system. And I already mentioned some of the plants growing in there. Daylilies are another great one that do well with lower water, and edible flowers and daylilies too. Great sauteed stuff with goat cheese. So here's a picture of echinacea, and here's a native orchard bee that's visiting that plant, and it's just loaded with pollen. I love watching that on my landscape, and again, just a plug for a more diversified landscape and how much more fun those can be at the household level. So for maintenance, couple best management practices there is to make sure you are inspecting those discharge outlets and flow splitters for clogging, like I mentioned, inspect for signs of pooling or runoff. And I clean my system out about twice a year now. That seems to be the best for me and our water use. I can probably decrease that when the kids aren't needing a bath so often. Turn the three-way diverted sewer system as you need. If you're cleaning with any heavy chemicals, of course, turn that to the other way. Or if you're washing very dirty reusable diapers, you'll want to turn that to the sewer as well. Maintain your wood chip mulch. What we found in my system is that it's so active that water, obviously nutrient rich soil, and the mulch layer is breaking down relatively quickly. So every year to other year, I've got to put in a fresh mulch layer, pull out what's in there, and I use that as fertilizer around my trees in the back. And plant care for specific plant needs, and other information is deemed as appropriate per system specifics and or health official requirements. So just some major notes for your best management practices there. A plug to our fact sheet, and I'll put this in the chat here in a second, the link. And I'll just do it in a minute when I'm done presenting, but we wrote a fact sheet to make this understandable and easy for all to figure out what is gray water, how do you install this at the household level, what are some of the major things to consider, and what does the new code entail. So that was updated with the new rule in 2020 and is now available to the public, and I'll put the link in there like I mentioned. So hopefully now you have a better understanding of gray water, you've observed some system examples, and you can at least describe the really basic anatomy. It's super simple. I mean, for someone like me who this isn't my wheelhouse, of course, and I even understand how to install these systems, and it's not my area of expertise. And so amazing to see this happen, and I hope more health departments take this up in the future. And with that, I think we're going to move into Q&A now in the last 15 or so minutes.
Great, that was really interesting. Thank you for sharing that. So let's see, if you guys have questions, please use the Q&A box, and we will get to those. Kelly, do you have a question?
If I may, this question came up after the last panel, but it does relate to gray water, but it's really more directed towards you, Candace, and that was, are any of the landscapes on your demonstration street using gray water?
That is a great question, and they are not. And that is a really great segue into a question for Orion. So if you're in a region where health departments have not opted in, what options do those people have?
They can pester their health department until they opt in.
Cool, okay. Thank you. Since we're on that topic, and guys, if you have questions, please type them into the Q&A box. But since we're on that topic, for the health departments that have opted in to administering a gray water program, how has it changed their workload and responsibilities?
It hasn't yet, because there isn't enough interest yet to increase that workload. I'm not sure if there have been any gray water systems installed in any jurisdiction other than my own at this point. So really, it's time to advocate for them and get that interest out there. But in general, it's probably not going to increase. We already have on-site wastewater system programs, and this is an on-site wastewater system, and therefore, like, the staff's already there, and the permitting process is pretty much already there. Generally, the fee schedule is already there, so it just may increase the number of inspections and whatnot that we need to do through time.
Okay, thank you. Question about the mulch barrier. Would there be any benefit to adding charcoal?
Well, this would be more of a question for our soil scientists at USU, but my understanding of working with biochar, at least, is that it does help with retention into the soil of water. So especially if you have more compact soil, I could see charcoal helping with that water retention, and I could see that being a benefit. I have not used that in my own system, but that's a good question and a good idea for future research. Kelly, do you have any thoughts on whether that might help?
I don't know about charcoal specifically, but I do think it would be an interesting area to look at.
When it comes to treatment, I don't see that it would be necessary to add the charcoal for treatment of the bacteria and whatnot, just because you're going to build up such a nice biology within that upper layer, that aerobic upper layer of the soil column, that we're going to be seeing quite a bit of treatment. For perspective, like with a septic system, generally you see treatment of pathogens within 3.5 feet of travel through the soil column.
Interesting. So talking about plants in the gray water system, is it possible to use the gray water on a turf, like a pressurized irrigation system? And has anyone done this? Do you have examples?
No, at least in Utah, with the way our rule is, maybe for like a subsurface strip, because we require all discharge of the gray water to be a minimum of 6 inches below the surface of the soil, the mulch, whatever the barrier is, because we don't want to see that water, because there's the potential pathogens and whatnot. We want to minimize that contact with humans and prevent aerosolization and whatnot.
If I may add to that, so I've done a little bit of research, not directly with overhead spray or drip on turf with gray water, but more of a preliminary work just assessing the capacity of gray water for use with turf, and had really positive results with that. Personally, it's something I think has great potential. And in fact, with turf, there's such an extensive root system that it can be a fantastic plant system for retaining and using some of the nutrients that we get with gray water.
Great, I'm glad you added that. Are there any concerns with reducing the amount of liquid that's going through the sewer system from a municipality standpoint?
At the current scale of gray water use, no. If there was a municipality that, people got really excited about gray water and started reusing a ton of it, and the sewer treatment plant was old and worn out. So, for instance, the Moab sewage treatment plant just got replaced, and the previous one they had to add water to. But now we don't have to add water to it, but we also don't have enough gray water happening to cause an issue. So it's very, very case specific as to whether or not that could be an issue. But with the scale we're seeing, I mean, the scale that we could even predict for a long time, it shouldn't be an issue.
Sure. So what do you do with your gray water system in the winter, especially if you're in an area that's been freeze?
Well, this has been a fun experiment for me over time. The last 2 years, I actually did not turn my gray water off because I monitored and wanted to make sure to see what happened with that in Moab in the winter, and I've not had any issue with backup. That water is warm coming up. I do not advocate for that at a larger scale, and hope I'm not making you nervous letting you know that, Orion, but that's been a really fun thing to know, that in Moab that it is possible if you did have a homeowner who forgot one in winter, at least from my personal experience, has not been any issue. There's been absolutely zero backup. Now, of course, northern Utah is a much different environment than Moab. And so you're dealing with a much longer hard freeze season. And all you need to do as a homeowner is turn that Jandy valve to sewer for that winter. And that's what I do most winters. But the last two, like I said, I experimented to see if I could just continue feeding the landscape without issue and any backup, and did not have any problem down here.
So long as the water's not surfacing, as a public health official, I wouldn't care at all. So
yeah, great.
Cool, good to know.
Real quick, there's a couple great resources I wanted to share.
Yeah.
I shared something in the chat that just in Tucson, Arizona, the city now requires mandatory gray water stub out on all new construction. And Ryan mentioned this in his presentation as well, just that I hope it's a direction we're heading here in Utah. If we're going to be dealing with drought seriously, this is a very easy thing for a homeowner, very inexpensive at least to stub out, and requiring that on all new construction would be a leap from our current practices. And if you're interested, this is a good resource that's commonly referenced, Creating an Oasis with Gray Water. There's a more technical version by the same author that's for builders. So just Art Ludwig is the author of that one. And then this is a new book that has come out that I really have enjoyed. It's Gray Water, Green Landscape. And the author of that is Laura Allen. And that has some great images, drawings, and technical specs in there. And then lastly, Laura Allen also wrote this Water-Wise Home. That is another great resource for that. So it's how to capture and reuse water, conserve, capture, and reuse water in your home and landscape, gray water reuse, rainwater harvesting, and waterless toilets. So for those of you interested in a deeper dive, those are some great resources for that.
That's awesome. Thank you for sharing that. So just kind of talking about if a homeowner does install this, what kind of considerations do they need to have when it comes to detergents or shampoos to make sure that the soil health stays optimal?
Roz might expand a little bit after me, but we actually, within the code, which is kind of an oddity, is we actually included a best management practices section as an appendices to the code, which describes kind of some of the better things to do or to not do. When it comes to the soaps and whatnot, like ideally you would use certain soaps that are more appropriate, but we've seen other gray water systems where really no change in the owner's practices happened, and the plants seem to generally thrive either way.
So in the code, it states the use of plant-friendly products is important when using gray water for irrigation. Products should be salt and borax-free in addition to being biodegradable and non-toxic. Plant-friendly products are key when reusing gray water. Chlorine bleach can be harmful to plants and should be diverted into your sewer system. Hydrogen peroxide-based products can be used instead of bleach. So this is it is an interesting thing to have in a code, and I think it's great that that was included as a guide for people to reference. I generally look for lower salt content when I'm purchasing products to use in the shower and my laundry, but I also have at times just bought something that was all natural and not paid much attention to the salt content, and I've not had an issue with my plants with that. So I generally look for that lower salt content, but as a working mom, sometimes don't take the time to do that, and it's not been an issue for me. I always tell people when it comes to the products you're using in your system, if it's harmful to your soil and to the biological soil health, then it is likely also harmful to your skin. So just a consideration as we think of this from a more integrated perspective, and might not be a bad thing to switch to more natural-based products anyways when it comes to that.
That's good information. I see a couple attendees with their hand raised. If you guys have questions, just type them into the Q&A box and we'll get to those. Back to the health departments that are not opting in just yet. What are some of the concerns that they have, or just health departments in general?
A lot of it has to do with staffing. Some health departments do a lot more on-site wastewater work than other health departments because, the majority of the Salt Lake Valley is sewer, right? So they're not going to be doing as many on-site wastewater systems as you might see in, like for me, Carbon and Emery County have a lot of wastewater systems going in. We have a few in Grand County every year. And, so it's every health department's unique in their ability to be able to administer it. And I mean, if suddenly there was 100,000 people interested in Salt Lake County in a gray water system, it'd be very hard to handle that. I think would be the primary things.
That's a fair concern. Orion, when you were talking about the subdivision in Moab, you mentioned that the lot sizes were a little small, and then there was a reference to accommodating setbacks. Can you elaborate on that a little bit?
Yeah, it's actually something that I found very interesting in the last few weeks because this thing's starting to go, and I've had plans submitted to me, and the areas where maybe would be ideal to put the gray water system. Within the rule, you have to be X number of 5 feet from the foundation, 5 feet from a property line. But if there's only 10 feet between the house and the property line, we can't fit it. And so we're having to figure out how to move that, either split the system into 2 different sizes and be able to have some of the water go to the front of the house and the water go to the back of the house, have the washing machine go to the front and the bathtub go to the back of the house where there's a larger setback, that sort of thing. So one consideration when we are making these affordable lots, if we're going to do gray water systems or whatever, we need to make the lot big enough to actually be able to do it.
Great, good to know. Roz, kind of a fun question. Do you have any idea how much water you're harvesting from your gray water system?
Gosh, it's a great question. Right now, I'm doing a load of laundry every other day. So I get that coming in every other day, and then the kids have a bath every other day. And so there's those 2. I didn't pull out from my bathroom sink, and I could have, and I actually regret not, because at the time I didn't have kids, and Dan and I weren't sure if we were going to, and we're both very water wise, and we knew that with toothpaste that would be a higher salt content flow of water, and so we decided to just put that down into sewer and not to our gray water system. Of course, now with little ones, all of you listening in that have little kids know they turn the faucet on and like to leave it on no matter how many times you ask them to turn it off, and so a lot more water is going in there than I expected. I mean, it's not a crazy amount, but I do wish that we'd pulled out from that. So that would be a bath every other day, load of laundry every other day, and my husband and I showering every other day. So I guess that was the amount of water, and I've never actually calculated how much it is. That would be a fun thing to do, but I haven't done it.
Very curious.
I have an Excel sheet, or I have a spreadsheet somewhere. I'm trying to find it.
Oh, to calculate potential harvest?
Yeah, I've always just used those averages that I showed in the slide of the fixtures and the average amount per household.
I wonder if you could meter that, or if the salts in the water would. I wonder what the lifespan of your meter would be. Okay, next question. So this is a good one for those that are not building a new house, or maybe someone that's in a rental, so they don't have the options to really do a lot of retrofitting, or if you're in an existing house, not building a new. What are some options that those folks have for gray water?
So let me make sure that, so if you're renting the home, what are the options for people to do?
Maybe as I said it kind of went 2 directions. So if you're renting, are there any options? And then if you own an existing home, you're not building a new home, what are some options there?
So if you own an existing home and it's already been built and whatnot, it's very specific to the case specific whether or not you can pull off doing a gray water system. If you're in a house that's built slab on grade, all the plumbing is underneath your concrete. It's going to be very difficult unless, for instance, your washing machine is placed on an exterior wall. And if it's on the exterior wall, it's going to be much easier to divert that water to the landscape. So Roz mentioned using the Jandy valve, one of those, or you can also have, behind your washing machine, you have a standpipe that little hooked hose goes into. You can install a second one of those. One of them goes to sewer, one of them goes to your landscape, and then you can just swap that hose back and forth, just like you would do with the three-way valve. So, and then as a renter, you just have to work with your landlord to do something to make a modification to the home similar to that. And again, it would just be very case specific. So like my house, I'm never going to have a gray water system because it just isn't plumbed in such a way as to be able to do it.
So in Albuquerque, when we installed the gray water system at a residential home, we did exactly what Ryan said with the laundry system. So that house was already built and we were coming in after the fact and putting gray water in. And we had that water, the homeowner could choose whether that was going to landscape or not by installing that extra pipe, and then that would flow out to the landscape. And then we were able to pull from all the other fixtures because there was a crawl space under the house. And so we went under in that crawl space area and under the foundation and were able to, they put the Jenny valve in to a convenient place in the house, and then we dropped the pipe down below the house and brought it out to the landscape. And so it really is case specific. As he mentioned, if your whole home is poured concrete, it's going to be very difficult unless your fixture is right next to the outside of the house. And there was a way to plug in a three-way valve right at that fixture.
Great suggestions. I also liked your clean water suggestion that you mentioned during your presentation where you have your bucket right behind the sink.
Yeah, we do that every day.
Let's see. Okay, I think we are actually right on time. So let's, I just want to thank you guys for doing this. This was a fantastic panel. For those that were a little late or just want to recap, it is being recorded and we'll get that posted and emailed out to you shortly. And if you need CEUs, I will send that email out later today on how to get CEUs for attending this. This was fantastic. Thank you guys. I really appreciate it.
Thanks. It was fun.
Well, thanks for having us. And if anybody has any questions, feel free to call me.
Cool. Sounds great. Thanks, guys.
Go find me.